So yes, as he mentioned, I'm with the Department of Conservation and Natural Resources, which underneath of that falls a number of bureaus. I'm in the Bureau of Forestry. And I am a forest ecologist. I work on rare plant and wildlife protection or management on state forest land, and I also coordinate our climate change efforts in the Bureau of Forestry. I just also want to tell you, as I go through these slides, you're going to see some QR codes on some of my slides, and if you want information about things, just hold your phone up, take a picture of it. You should be able to reach those documents that way. And if you want to come out at the end, you can also look at them then. So I'm going to just start with some information about climate change, what we expect it to look like in Pennsylvania within the century, as far as just heat and precipitation. You can see here that the darker the red, the more days that we expect to have temperatures over 90 degrees Fahrenheit throughout the state. And the more blue it gets, the more days that we expect to have heavy precipitation in the state. So this has a lot of, as you can imagine, a lot of implications for natural resources. And that's what I'm going to talk about today, is how we're adapting and mitigating or lessening the effects of climate change on natural resources on our state forests, and I guess on some of our other land too, like parks. But these are just some examples of how we expect to see climate change affecting natural resources, and some of them are probably pretty obvious. Extreme flooding, and erosion. And today we're talking a lot about watersheds, and erosion can cause stream quality issues, of course. We also are expecting to see more tree fungal diseases, because if you think of hotter and wetter, that's fungus, right? So we are seeing that sometimes already with things like chestnut oak. And sometimes we might see some drought as well, which kind of doesn't make sense at first, but when you think about the projections are kind of like, we might have lots of heavy precipitation and then a long period of no precipitation and then a heavy downpour again. That's kind of what they're expecting to see. So in those periods in between, we might have drought, which then can create wildfire issues. There's also kind of a theory that with snow cover decreasing in some areas, that could damage roots of trees, because snow kind of acts as like a little insulation to some root systems. And then something you're probably noticing yourselves is early flowering. Some of the early flowering species might lose their buds when frost kicks in again, and that's kind of happening right now probably. Also, tick and mosquito-borne diseases are something we're really keeping our eye out for, because you get hotter and wetter, and you're probably going to have more mosquitoes and hotter ticks. So that's the bad news, right? And I will get to how we're trying to address these things at DCNR on our land, but I think it'll be helpful to first give you sort of a quick review of what is causing climate change, and that's essentially the greenhouse effect is trapping greenhouse gases into our atmosphere, and that warms the earth. And we have been we have been emitting more carbon dioxide, which is one of the greenhouse gases, into our atmosphere more and more over the past 150 years or so, which makes it warmer and warmer. So you can see the chart there at the bottom shows how much it's been going up, CO2 levels, carbon dioxide levels since 2015 even. And the EPA says that the primary causes of the CO2 emissions increasing over this past 150 years are from burning of fossil fuels. And that includes electricity, transportation, heating, primarily. So, I want to also give a little bit of attention to methane, another climate change producing greenhouse gas or contributing greenhouse gas. Methane is kind of the second most worrisome of the greenhouse gases for climate change because it also traps heat into the atmosphere, but at a much higher rate than carbon dioxide. So it traps a lot more of it a lot faster, and then it fades away out of the atmosphere after about a decade. Whereas carbon dioxide traps a lot of heat, but it doesn't fade away for centuries. So that's why we're more concerned about carbon dioxide than methane, but we should also care about methane because we don't want a lot of that either. So in Pennsylvania, we have a lot of oil and gas wells that are across the state that were created a long time ago, some of them, and they have been leaking methane into the atmosphere. The Department of Environmental Protection has worked with DCNR to flood those wells that are on our state land. And it's an extremely expensive process, which is why it takes a while. But we are making some headway on that, and I'm really proud of that work. I don't do anything with it myself, but I'm proud of the people working on that because I think it's really important. Pennsylvania is the second most methane-producing state next to Texas. So it's a great thing to plug these oil and gas wells. Other things DCNR has been doing across all of our bureaus is we have a whole fleet of electric and hybrid vehicles now. We have public charging stations for electric vehicles. I don't know if anyone's seen them or maybe used them. A lot of them are at parks. Keep your eyes open for that if you have an electric vehicle. And they're free to the public to use. We have lots of LEED certified buildings, and just we've done a lot of work to make our buildings high efficiency in lots of different ways for energy use. And we have a goal that by 2030 we'll derive all of our electricity at DCNR from renewable resources. We also recently came up with a grid-scale solar array siting guidance document. If you've heard anything about this, it's an interesting problem that's been happening in Pennsylvania over the past few years, where maybe you have a big chunk of land and a solar company calls you and says they want to pay you for some of it for solar. While solar is great and we love solar panels, sometimes people are cutting down large forested areas to put up solar panels, and that's pretty counterproductive. So we don't recommend that anyone cuts forests to put up solar panels, but some of the companies will just tell you you should do it anyway. So we have a guidance document for a lot of townships, maybe so that they can create ordinances for solar siting. That's probably the best way that you can prevent that from happening where you live. It's through your township ordinances. We also have the DCNR Climate Change Adaptation and Mitigation Plan that was created in 2018, and we are currently updating it. It's going to be updated this year. And the way that, I'm going to just go into this a little bit. This is something that I work on a lot at the Bureau of Forestry. We consulted with the Northern Institute of Applied Climate Science to create this document, and they're very willing to help anyone who wants to have a plan like this create it. They work with us to figure out what our vulnerabilities are in DCNR land and in our operations, and then the risk level of each and the actions that we can take to address them. And then in the back of the plan, there's a section that talks about the Climate Change Tree Atlas, which gives you an idea of what the best and kind of worst trees are to plant based on how they might do in the future with climate change. So we are also, something that DCNR is doing more recently, we're working on a carbon footprint analysis. So we basically want to find out what are all of the sources of carbon dioxide that we are emitting as an organization, so that we can then address them and try to reduce the amount of carbon dioxide that we're emitting. And the way that you do that is by doing a carbon footprint analysis. So we're going to be finishing that up this year, and it includes the scope 1, 2, and some 3, and that means what that means is that the scope 1 is emissions that occur from things that we're doing that are owned by us, like say a ranger's truck emitting carbon dioxide into the atmosphere. Scope 2 are things that we purchase that create carbon dioxide, like electricity for a building. And then scope 3 are emissions that are occurring kind of indirectly. So if you are commuting to work, like what is the amount of carbon that you're emitting doing that? So these are the sort of information that's going to go into this and help us figure out where we can change things to help our carbon footprint be smaller. For the Bureau of Forestry, we came up with a carbon management principles document. We were getting a lot of questions from people about, how can we sequester more carbon on our forest land or store more carbon? So we created a document. There are a few copies over there on that table. We're just trying to get it online now, but it's not up there yet. If anybody wants one, and there's one over there, just ask me for one. I'll get you one later. But it's a list of ways that we can sequester the most carbon we can, and the main take-home message from it is healthy forests are going to sequester more carbon. So anything you can do to make your forest healthier is going to help. And that's, invasive species control, deer control, pests like spongy moth or any kind of pest that comes in and kills your trees. We want to prevent them from killing your trees. The more live trees we have, the more carbon that's sequestered. And so I'm going to kind of switch gears a little now and go over the projects that just the Bureau of Forestry is working on, and these are more things that I'm sort of involved in and might know a little bit more about. The first thing is just we've been working on a number of different research projects to look at carbon sequestration and storage, and we're working with different universities on this. We're looking at the impacts of different kinds of forest management on carbon to see, if you can do something differently to sequester more carbon the way you manage a forest. We are looking at an inventory of legacy mine land across the state, because that might be an opportunity where we can plant trees in order to sequester more carbon. And we're also doing a modeling and mapping project to predict how much carbon is on our forest land right now. Because you have to kind of start with what's there to figure out if we're, over time, getting more of it or less of it, or, we can change anything we're doing to help that. And then we also have changed the way that we manage our stream crossings, and this is kind of what we were talking about before I started speaking. So we have road improvement projects and stream crossings that go, that we have bridges and culverts for, and we used to design them in a way that they would be, they would be able to handle a 50-year storm event. So that is kind of what it sounds like. Every 50 years, there's a big storm event. Your culvert needs to be a certain size in order to deal with it without blowing out. We were seeing so many of those that were not within 50 years, but in a shorter time frame, that we've started designing our stream crossings for 100-year storm events instead. We don't really expect that it's going to take 100 years to see those storms, but that's what they're called, because that's the size of them. We're also doing planting and monitoring of climate change resilient tree species on our state forest land. This is kind of getting back to what I was talking about earlier with the climate change resilient tree species. And we are also doing some migratory corridor work that I'm going to get into later. I'll explain what that's about at the end of my presentation. And then you can see on the right, I have the different kinds of buffer programs and tree planting programs that we have. That's the number of trees and acreage that we've planted. And then we have a lawn conversion program, like what they were talking about in the keynotes. And I have some informational brochures over there about our lawn conversion and riparian buffer programs, if anybody wants one of those. Before I kind of get into the next part about how we determined our climate change resilient trees, does anybody have any questions yet about anything I've said, or about anything that I've talked about so far?
You mentioned climate change migratory corridors and land acquisition. Are you going to explain that a little bit more?
Yes, that is going to be at the end of the presentation. Yep. Anything else?
With your electric vehicles and stuff, are you taking into account where the electricity comes from as part of the, coming from the power plants?
Like for our carbon footprint analysis, or just?
I guess just, or just in general,
I don't know, honestly. I know a lot of them are at state parks, and we do have solar arrays at some of our state parks, so I would love to know myself if they're connected.
We are paying attention to where the electricity is coming from. That's part of the package deal where we're trying to buy in bulk for ourselves as the offset.
Are you with the...
I'm sorry, I'm with DCNR.
Oh, I'm sorry, I didn't know that. Are you with state parks? Or?
No, I'm with Bureau of Recreation and Conservation.
Oh, great. Oh, okay. What's your name?
My name is Drew Gilchrist.
Okay, nice to meet you. I'm glad you're here to back me up, and that's great to hear. Thanks for answering that.
And then the other question that I had is, North Carolina Township is developing an ordinance to deal with solar arrays. Is there an organization that could look at the ordinance that we're developing, so to make sure that it addresses the concerns of the Forest Service?
So there was a group of people at Penn State that was doing that. They actually have a template that townships can use for their ordinances. I think there might be like a link to that or some kind of information about that in that brochure, or not that one, but the QR code that I had up for the solar ordinances.
Okay.
Or solar siting. There is someone doing that. If you want to come to me afterwards and remind me, I can look into that for you more.
That would be great. That would be great. Thanks.
Yeah.
One thing real quick, I just mentioned to answer her question. There is a page, a local government page on DEP's website with example ordinances for that exactly. I actually had that updated yesterday.
Oh, great. So, and could you introduce
Yeah,
yourself?
sorry. Christopher A. DEP. I work in the Energy Programs Office.
Okay, great. So I love that people are here that can answer the questions that I don't know the answers to.
Sorry, I didn't want to like jump.
No, that's wonderful. So it is online.
Yeah. Yeah, Cumberland County just sent me an update to their ordinance yesterday to update our website.
That's great. Okay. Yeah, I think that's a really great service. I mean, I wish that all the townships would do that. Okay, so we're going to get into sort of some sciencey mapping things here. If anybody has questions while I'm going through it, feel free to raise your hand and ask. So the Climate Change Tree Atlas is something that we used. I mentioned it before. It's the Northern Institute of Applied Climate Science produces it, and it is a model, so a spatial model that projects the ability of tree species to cope with climate change into the future. And it runs on information about the habitat suitability that we expect to see in the future on the ground, and the species traits of different trees, and then also their potential to migrate. So you might think at first, wait, trees, how can a tree migrate? It's not an animal. But they are moving by seed dispersal. They just, seeds, and animals move seeds, and then the ones that survive are the ones that are in a habitat that is going to be beneficial for them to grow in. And if it's too hot, for instance, that tree might not survive. But the one that blew seeds up north a little farther, where it's a little cooler, maybe that one survives. And then it just moves up and up and up. And that's how trees migrate. So the Northern Institute of Applied Climate Science helped us in DCNR to make that list of trees that I was talking about by looking at different regions of Pennsylvania and looking at how tree species will do in each of those places, because it's a little different depending on where you are in the state. And then when we consulted with them recently, like after that plan was written and the information in the back that shows the tree list, we noticed that some of them didn't make a lot of sense to us. Like they were saying that green ash, for example, might do better in the future. And we said, no, not in Pennsylvania. So we talked to them and they said, we really need to look at the model information that's in that plan as kind of a starting point, and then use your local knowledge of forests and of Pennsylvania habitat to tweak it to be what a little more accurate. And so things like green ash, elms, black cherry, and sugar maple, they all have problems right now with either pests killing them or just some soil issues where they're not growing that well. So if a tree is not doing well now, we expect that it's not going to do better in the future with climate change. Basically, it's the theory of a threat multiplier. So if you have something going on, like a pest is killing, an emerald ash borer is killing green ash, and then you get invasive species that it has to, like, I don't know, oriental bittersweet climbs up it. That's another threat that it has to face. And then if you get climate change on top of that and it's too hot for it, that's another threat, and it's probably just not going to survive. So climate change is like that. If you have a healthy forest, like I said, it might be more resilient to climate change. But if you have a forest that's being threatened already, or a tree species that's being threatened already, it's probably not going to do that great with climate change. Then also, on the other hand, the tree atlas said that pitch pine might not do that great, but if you look into it more, if any species that the tree atlas says won't do well, if you're going to actually plant it and take care of it and maintain it properly and put it in the right habitat, then it has a much better chance of surviving with climate change than what this model projects. This model is only about a tree getting to a certain place on its own and staying there and surviving. It's not taking into account any kind of management that you're doing for it. Another thing to consider with this tree atlas is that certain species are recommended, or not recommended, but it says will do well in the future. But if you were to plant it right now, it might not do that well. So again, it's about over a long period of time what will make it here on its own. But if you were to take like a longleaf pine from the south and plant it here now, it might die in a big cold snap, next year. But maybe it'll make it here on its own in the next 75 years. So just some things that we were looking at, that we used in order to get a better list of trees together. We also looked at all of these characteristics. We talked to, like I said, the pests and pathogens were big to consider, and we talked to we did a survey for a lot of our foresters to see what they're actually seeing on the ground, and then we looked through our inventory that we do on the ground all the time to look at current regeneration and survivorship of certain tree species. And if something is already just not regenerating well or not surviving well, we kind of just axed it. That's probably not going to do well in the future. And I mean, we could be wrong. This is all just projections into the future based on what we know now. Things could change, but this is our best scientific guess. These are the general species lists that look like they'll do the best or the worst over time with climate change, based on that whole characteristics that I just went through. And you can see that there's not a lot of conifers in there. For best choices, conifers are not looking like they're going to generally do as well, especially spruces. I'm sure that hemlocks are not looking so great because of hemlock woolly adelgid. So, we would recommend hickories look great, yellow poplar, basswood, black gum. Even considering if you're kind of in the southern part of Pennsylvania right now, or this area, something like southern red oak and sweet gum, those are things that are already kind of in the state, but only just barely into the southern part, and they will probably continue to become more prevalent in Pennsylvania over time. So maybe think about those if you're looking for some species to plant. So part of what I said about I just want to kind of go back to what I said about this. The tree list is kind of theoretical based on best guesses, right? So the way that we get more information is by doing experiments on the ground. And so we have set up a few experiments on the ground on state forest land in order to start testing these theories. We worked with a Penn State PhD student from the K Forest Dynamics Lab. It was really, she came to us and we just sort of got more involved with her project and recommended certain species that she could try. This is us planting on Rock State Forest. And she and her lab are going to be taking measurements of these trees over time, just kind of indefinitely to see what survives. And they're going to compare the species that are more kind of new arrivals, as we're calling them, like southern red oak and sweet gum, to things that we're used to seeing here, like northern red oak, and just see which ones do well over time, so that we'll know which species we can actually recommend to people. We've done the same thing in Michaud State Forest and Buchanan State Forest. We were about to do that this spring. They were already doing projects where they're planting trees and just for restoration of some sites. And we just said, hey, do you mind if we just plant a few of these interesting different trees here and we'll come out and keep monitoring it for years to come. And so that's how we like to get a lot of things done in your forestry, is sort of like stacking things so that you can, as a friend of mine says, feed two birds with one seed instead of the more aggressive. That's what we have been trying to do, and I would encourage, other people to. Actually, I was going to say I was going to encourage you to kind of do that on your properties too. But the reason why we're doing it the way we're doing it is because we can go out and monitor them and take data on them for years to come. Because we don't really know what to expect yet, and if you just plant things like, if you were to just randomly plant like a loblolly or something, you might then find that it becomes aggressive and takes over certain areas, and if you're not monitoring it closely with scientists who are used to looking at these things and treating them, you might end up with a problem. So I don't want to recommend that you do it unless you have a setup for some scientific monitoring, but that is something we're able to do right now, at least on these 3 sites on state forest land. And we're just this is a picture of some of us taking data at one of those sites, and it's just, regular data to figure out what kind of, how healthy the trees are, how much they're growing, if they're surviving, if they are facing any kind of disease, or like if we see fungal disease, we're going to note that so that we know maybe this tree species isn't going to do so well in the future with fungal diseases being more prevalent with hotter and wetter climate. So this is the last project I kind of wanted to go over. This is the climate change connectivity project that I was talking about earlier. And it's basically a way that we could figure out where the most connected pieces of land are in the state, and that helps us with when we're prioritizing what parcels we want to acquire or protect. And it also helps us in other ways, but just want to kind of go over first what that means, like what is connected landscape and why is it important. So if you look at this diagram, and I apologize, it's kind of small, I don't know how well you can see it, but if you think of this like elk habitat, for instance, and there's a patch of elk that live in the forest here. We're looking at like an aerial view, right? So there's a forest habitat here, there's a forest habitat here. Elk live in both places. They need to be able to find each other by connecting those two patches of habitat or forest. And if they can find each other, then they can reproduce and they can be a healthy elk population. If there is a corridor of trees or some kind of forested area in between those two patches, then they will be able to move back and forth and find each other. And then this over here is more kind of what you see with like species that can fly, like birds or insects. They can hop from stepping stone habitat to stepping stone to get to their patch. But that's very important to them to have a stepping stone habitat to move in between where their populations are. So this is important to climate change because, for instance, an elk generally likes cooler climate. That's why they're in the north of Pennsylvania. And as climate changes, they're going to want to move north to find that cool climate. So if they are in, this patch here, and suddenly there's like a shopping mall built in this corridor, then they can't get north to their cooler climate patch or to find their mate. But that's why it's important to have corridors, and that's why we wanted to know where they are. So I should have said, the Western Pennsylvania Conservancy is part of the Pennsylvania Natural Heritage Program, and they were the ones we contracted to do that work, to create that model to show us where these connected properties are. And we have actually added it to our website at the Pennsylvania Natural Heritage Program, P&DI. I don't know if anybody knows what the P&DI is, but it is a place that people go to get clearance for projects and do conservation planning. And if you wanted to see it and use it, you could go to that website and then look for climate change connectivity right here, and it'll pop up in the map. And you can also view the description of what it is and see a link to that story map that I had on the last page. The story map is really nice. WPC did a great job, Western PA Conservancy, with that, and it kind of goes through everything that's in it if you're interested in learning more about that. The way that we integrated that information into the way that we acquire land in the Bureau of Forestry, is we have this tool that we call the Prospects Analysis Tool, and it's basically a mapping tool that takes all of these different characteristics, puts them into a big map, and if we see that something meets a lot of these criteria, then it's more interesting to us to acquire. And so we, a few years ago, added the climate change connectivity corridors layer to that map. And so now that is something that we consider more heavily if we wanted to acquire something. So this is my last slide. I just wanted to kind of talk a little bit about general management of forests and how you can manage them for climate change to make them more climate resilient. These are all things that we do at the Bureau of Forestry and recommend that anyone with a forest would do. So we maximize the diversity of the forest, and that means the species, the structure, age, quality. Phenological diversity is just like when it flowers, what time of year it flowers. So that, if you had a forest that's all things that flower in the early spring and then you get a frost, it kills your forest. But if you have things that flower all over, throughout the year, maybe it does better. The same kind of thing with species diversity. You don't want necessarily the same species and just plant it everywhere, because if there's a disease or a pest that comes through that targets that one species, your whole forest is gone. But if you have diversity, some of it's still there. Other things to consider: planting on the appropriate site, of course. Also, when you're thinking about the seed origin, we used to say that you wanted to get all of your seed very locally, because that would be the most the healthiest population of that plant or whatever you're growing, if it was from local source. And that still is somewhat true, but a lot of people now, researchers are saying that it's a good idea to take some seed from a little bit south and a little bit east too, and if you can find them, and plant those with the locally sourced seed in the same place, so that if you were to get, a really cold snap, maybe the local seed source plant would survive fine, but the ones that were from the south, maybe they wouldn't. But then if you got a heat wave, the local seed might kind of die, but the ones from the south would live. So it's just another diversifying of what you've got there, so that you have the best chance of survival. Another thing is to try to avoid cultivars in a forested setting. That's because they are often clones, and then that narrows the gene pool. And you want genes that can adapt to different kinds of climate, like I was saying, so that they're more diverse, more adaptable. Then, like I was saying before, manage your other stressors, like deer pressure and invasive species. And then when you're planting conifers, make sure you mix them with hardwoods if you can, for the same reason I was saying before. There's a lot of diseases, pests out there that target conifers, and if you have all conifers, you might lose your whole forest. So mix them up with hardwoods. And if you're specifically planting conifers, at least space them out to less than 80 square feet basal area, if you can. And if you're in the south, especially like this region, that will help with southern pine beetle. It's something that we've been researching and noticing at one of our sites, that sort of spacing helps. The pine beetle actually can't fly far enough to get to the other trees if you space it out enough. So those are my recommendations for management, and that is kind of the quick overview of things we're doing. I'm sure there are many other things we're doing at DCNR for climate change that I didn't talk about. If anyone else from DCNR wants to say anything else that I didn't mention, if you know of anything else, you're more than welcome to. Or if anybody has any questions, I think we're
plenty of time for questions. So
okay.
Let's.
Yeah, I have a general question. Is there, when you're doing the evaluation to determine their resiliency, the species, is there any correlation between that and their ability to sequester carbon? Is there any relationship? Like, do the ones that have that resiliency tend to be better at it? Or efficient?
That's a really good question. I don't. Well, that particular characteristic was not considered in the model. So, but that could be true for some of them. But it is interesting you asked, because the PhD researcher that I mentioned at Penn State, who did the project with us, part of her question was, will these species survive that are from farther south? But the main part of her research was, can trees in general sequester more carbon based on the kind of geology, the bedrock that they're planted on? So she planted trees on shale, and then she planted the same tree species on sandstone bedrock. And there is evidence that I believe it's shale sequesters carbon better than sandstone. I hope I got that right. Her website, did I put her? Yes. If you look at that QR code, that's her website, and it gives.
And which one was that? I kind of grabbed as many as I could. Which? This one?
This one, yeah. I just moved it to it. Yep. That's all about her project, but it's pretty interesting, and she built off of somebody else's project too. So this is the second project showing the difference in bedrock makes a difference.
That was a follow-up question.
Aaron, a question about timing. How long does it take before you can say with any surety that you've got a species that's resilient to climate change?
That's a good question.
And the second question is, do you have enough time?
I would say you're never really going to know, personally, because you can only guess, but it's a moving target.
Yeah.
Because we're still changing in different ways. The climate is changing, and if we can do some things to change, our emissions as a society, then climate change might not be as bad as we're expecting it to be. But if we don't make those changes, maybe it would be worse. So a tree that does well under one scenario might not do well under a warmer scenario. So it's kind of you're kind of guessing, but the model that is used by the Northern Institute of Applied Climate Science, they give you two different scenarios, of one scenario being kind of bad and one scenario being really bad.
I've seen graphs of those things.
Yeah, so it's, and as we're doing these projects, I think we're just going to be able to say, okay, this one's still doing good. Like, this one's looking all right, and we're just going to be kind of hoping things keep going in a certain trajectory that's positive for the species that it's really going to be, I think the things that we're going to know the best are what is doing the worst. So as we're taking data, we might see this species keeps dying. This one has a new disease.
So you're kind of working from the other end.
Yeah, and then we might say, maybe don't plant that.
Yeah.
But so I think that'll be the more definitive answer that we get.
You have a great sort of oblique arrow perspective of climate change in forests. What scares you? What keeps you up at night?
Oh.
What aspect of this? So we know change is coming. Which one concerns you most?
As far as like the effects on the trees?
Whatever.
Well, to be perfectly honest, what scares me most is that we as a society are not going to change the way that we emit carbon into the atmosphere. It seems like it's been a real battle. I mean, we've known that we're doing this for decades, and yet we don't change. So, I'm very heartened to see that a huge agency like DCNR takes this so seriously, that we are doing everything we can, but I would like to see all agencies, all companies, take these steps also. And yeah, we're the Department of Conservation and Natural Resources, so we kind of better do that. But if more companies would take it seriously, do carbon emissions analyses, and actually make some changes, that's what we're going to need. That's what keeps me up at night.
Thank you.
I would say also invasive species.
Yeah.
They can really destroy a forest. So.
Invasive earthworms keep
Yeah.
the changing biochemistry of the soil.
Yeah,
What could go wrong?
that's actually a really good one, is soil health. I should have said something about that. Soil health is so important to climate change, to fighting climate change. If we can make our soils more organic and more just thicker organic layers in a lot of our soils, and protect some of our soils in our older forests, that they store so much carbon, and it can change the way that you farm to make it more sustainable and have better soil health. And that would go a huge way to help with climate change also. If more people did regenerative farming.
I wondered, is there any plans in Pennsylvania to adopt a carbon credit approach or carbon tax?
I don't think that the Bureau of Forestry is interested in that right now. It's kind of a complicated subject. Does anyone have?
Are you able to speak to it?
No. That is something that has been thrown around, and there's been talk about it and decisions about whether or not to put it into time plans. And for right now, all I can say is no.
Yeah, you have to be careful with carbon credits, because sometimes companies can claim carbon credits when they're not actually ending up reducing the total amount of carbon in the atmosphere. If the program doesn't require that you're doing something additional to take more carbon out of the atmosphere, like say you have a property and you already have, 15 acres on it of trees, you're sequestering a certain amount of carbon. If you get credit for that, you haven't actually done anything else to increase the amount of carbon that you're sequestering. So if somebody were to buy that credit and say, I'm going to now cut down this forest over there because this person has a forest over here that balances it out, well, you do, but you're not planting a new forest to make up for the forest that they cut down. You're just keeping things the same, which is good. You want to keep things the same, but you're not adding another value. You're not taking more carbon out of the atmosphere to, I don't know if I...
You're reaping return without investment.
Yeah.
And you're allowed to harvest that wood, what's the point then?
Yeah.
It should become old-growth forest.
It could be a great... I'm speaking for myself now, not DCNR at all. But
Well done.
I don't step in any problems with that. But from the way I look at it is, there's a lot of carbon programs out there that could be great. Some of them are great, but you have to really read the fine print and make sure that it's actually doing what it's saying it's going to do. And I'm not sure that we found one yet that we're ready to go there with as DCNR. But things could be happening that I don't know about. So maybe some others have found other programs that will work. I don't know, but last I heard, I think we're still looking for something that would be truly take carbon out of the atmosphere.
If you want to look at it in a real general way, what you're doing is instead of controlling carbon for the right reasons, you've now made controlling carbon a commodity.
Yeah.
And once it becomes a commodity,
It gets slippery. Yeah, people
You turned it into a
try to
casino.
make money out of it.
exactly.
Meredith,
Meredith, thank you. I don't want to mean to cut you off, but we are on a schedule. So thanks for the presentation.